Beautiful. So welcome to our webinar. We are presenting information from a unit that we helped kind of to adapt that's from OpenSciED, but it has lots of great New Jersey resources that can be used throughout really any subject and curriculum. So hopefully you'll be able to take away some of this. And if you have questions, please unmute, ask, or you can put in the chat as well. We'll do some introductions first. So I don't know, Renee, if you want to start, and then Eddie and I can go.
Yeah, sure. I'm Renee Hayter. I'm from Sustainable Jersey at the Sustainability Institute at the College of New Jersey. And I'm the deputy director, and I oversee the Sustainable Jersey for Schools program. And we're working with Rutgers on a project funded by DOE to develop curriculum resources that relate to integrating climate change into various topics and project-based learning opportunities.
Awesome. And then Eddie, if you want to introduce yourself.
Sure, I'm Eddie Cohen. I'm the Assistant Director for the Center for Math, Science, Computer Education. We've been around since 1984. Our name is before STEM. Someone just teased me earlier today about that. So we've been around for a while. We work with 2/3 of New Jersey schools. More recently, we're working with Sustainable Jersey, the DOE, and climate change education, creating curriculum, providing professional development, and resources for folks. And that's my background. My doctorate work is on using computer simulations in the classroom for middle school science teaching. And then the more recent work is similar in nature with using tech to support curriculum and instruction and students' learning of climate change, big ideas, concepts, and place-based education.
And I am Brielle Kochelik. I work with Eddie. I'm the Senior iSTEM Coordinator for CMSCE. So I help with getting any programs going that have to do with STEM, going into schools. We work with doing professional developments, and we also do programs with students. We've created a couple PBLs, design thinking within the climate world as well, on air quality and wind turbines. I used to be a middle school teacher, so I taught middle school science for 13 years. And then I have a doctorate in tech integration, so all STEM and related with science as well. So we are excited that you all are here. Thank you for joining for it. So this is our contact information, just in case you have any questions or after and you're looking at stuff, feel free to reach out to any of us. Rosalie is also part of this as well, which is Renee's program manager. So her information's on here too, with any questions. So kind of the game plan was to just do like a little bit of an overview of what OpenSciED is, because we took this unit specifically and kind of brought in New Jersey specific data, because the data in it was very throughout the whole United States. So we wanted to bring it in locally as well for it. So we're going to just do like a little overview of that and then go into a couple of the lessons. This isn't all of them. It would take like the whole day to do that. So we kind of just picked a couple, but we'll show you where you'll have access to everything to be able to see it. And then I put in, we did a webinar a couple weeks ago as well for data sets throughout different curriculum, or not different, well, yes, different curriculum, but different subject areas. So you can see that too, if there's anything that you're looking for to help out with colleagues. I know you probably know this already, but I linked them here just in case, the climate standards, but I think both of you know that this information. So, but that's kind of where we're working with. And then we're just going to do a little bit of a OpenSciED overview, because Veronica, I know you said that you're not using it. Susan, I don't know if you've had any experience with OpenSciED. So Eddie's going to take over that part a little bit and just give you kind of a brief overview, and then we'll get into the lessons. So Eddie, I will let you take it over if you want, and then I can click on anything or jump in as needed.
Yeah, I don't think people have to create a website, so we can probably skip that for now, but we have the links for you for the future. And then here's what the website looks like. The word where it says download this unit is really not downloading it. You're actually just opening it from the site. Just let everyone know. And then they have a storyline. If you want to go back to that, Brielle. So these are the two kind of main things, and we're going to use that storyline that we modified for you all that will give you access to. But in OpenSciED, the storyline is the multiple day lessons. So it says lesson 3 here, but that's 2 days, right? Lesson 2 is 3 days. So the first thing you should know about OpenSciED is when it says lesson, It's not a 1 day thing. It's normally, 2, 3, or 4 days. There's only like a couple 1 day lessons. So this is called the scope and sequence for OpenSciED. And we're going to show you our modifications to that.
And I downloaded it already so that you can see the curriculum too. If you want to see any of it, it is free to create an account. The whole thing is free, all of their curriculum for it. It's a national thing, New Jersey. It's the first time they've actually suggested a curriculum on the DOE site for science as well for it. But you can access both all of the curriculum, and it's all digital in Google Drive as well. And then that website just takes you to be able to register for it.
So this is the scope and sequence that New Jersey is using. This is the original OpenSciED scope and sequence. Massachusetts, for example, adopted and modified the order of things. We can see grade 6, grade 7, grade 8 all start with physical science first, and then they move down to earth or life science. We're going to specifically look at grade 7. The last unit is natural resources and human impact. We looked at all the OpenSciED resources and saw what made the most sense to add New Jersey climate data into the unit. And I said the word add, but really we're looking at what the unit objectives are, how the unit works, and what data they're using, and said, hey, you're going to use this data. Here's also New Jersey data that aligns to these goals and objectives that you can use in addition to, instead of, or however you want. So we basically looked at the unit and said, hey, here's what OpenSciED's doing, and here's what New Jersey data correlates there. We are certified to provide OpenSciED training in Rutgers. We just got a certification last year. I'm actually going to jump off this call to go on an OpenSciED meeting, which is pretty cool because it's a national organization. There's 36 different organizations that are providing PD for OpenSciED, and we're all meeting for the first time at 4 o'clock today. So that's kind of how it works. So we're all kind of trading ideas back and forth. And this is I call it the snake, but this is how instructional models work with OpenSciED. The middle school and high school is very similar. Middle school is out. What you just saw, the scope and sequence for middle school is out already. Access to everything is live. It's been live. Some districts have been using OpenSciED for 3 years if they were piloting. High school just finished piloting. High school, all of the biology units are out. Some of the chemistry units are out, and some of the physics units are out. By the end of the summer, they should all be out. Elementary, the first unit is supposed to be released for each grade this summer. So for K to 12 curriculum, that's where we're at. The elementary version of this looks different. It's smaller. Elementary teachers don't have the same amount of time that middle school, high school teachers do to teach science. So their scope and sequence is different.
And it's nice is that it truly aligns with NGSS because it starts out with an anchoring phenomenon for each unit, and then that's answered throughout with like a driving question board, putting the pieces together, investigation, problem solving, coming back to those, like you're constantly coming back to those questions that they come up with at the beginning of it, which is great.
And then here's the main, vocabulary words, big ideas. If you're not familiar with NGSS, OpenSciED was designed because next generation science centers came out. Curriculum was created. People got together and said, hey, I think we can do a better job making better curriculum, and let's make it accessible and equitable for all. We're gonna make it free, right? So it's the best curriculum that's out that I'm aware of. It's winning all these Green Report awards, and oh, by the way, it happens to be free. So it's based on the NGSS routine. So this is the research from 2017 of next gen storyline. So these key ideas are anchoring phenomena, navigation, doing investigation. I personally used to use the word labs. I'm old. I've been teaching for 20 years. So now they use the word investigation, which could mean simulations. It could mean phenomena is being invested through a hands-on experience. It could be, using data in a different way. So an investigation could mean a lot of different things. It's not just a hands-on type lab. How you put those investigations and the building blocks for core learning ideas together, just putting the pieces together, how you're using those ideas across multiple lessons to figure things out, and the problematizing, right? So those are the big parts of NGSS that OpenSciED is based upon. Questions so far? No. Okay, so the OpenSciED storyline we showed you before, Brielle can open up the link, and we'll put it in chat to make it easier for you all. So this link is the link that you can see the original one we showed you a second ago. On the right side, we added in New Jersey supplemental resources and then a teacher support sheet. So we didn't
And-
take away anything. We said this is a supplemental stuff. If you were going to do this lesson, here's the resources you would use. And here's the data that directly correlates with what OpenSciED is asking. And they're asking about water and temperature, right? So they're focused on flooding, heat, those ideas. So it's pretty easy. Droughts, it's easy to get New Jersey data, right? To support and make it more place-based and local to our students.
And the overarching question, which you can see at the beginning of the storyline, is how do changes in our systems impact our communities and what can we do about it? And then we'll go into the lessons, but it goes into flooding and drought, it goes into temperature, it goes into air quality, and then ending up with like, how can you in your community or schools address these problems going on? Is there ways to mitigate it or ways to like stop it from increasing so quickly for it as well? Then here.
And everyone can get access to that document, right? All right. So
Yeah, or they should be able to.
So the driving question Rail mentioned, how do changes in Earth systems impact our communities? What can we do about it? So that's the big driving question for the whole unit. If you notice, these are split into lesson sets. All of OpenSciED is split into multiple lesson sets. Some have 2 lesson sets, some have 3 lesson sets, some have 4 lesson sets. This paper is in the teacher edition on page 34, I think.
Yep.
In between the lesson set 1 and 2 is where they do the problematizing and they have a transfer task assessment comes in there. Then after lesson set 2, problematize, transfer task again. For example, after lesson 1, after lesson set 1, what is causing changes to water resources in these communities? Students wonder why all communities are having increase in air temperature, right? So kind of that's the big wondering the kids are having at the end of that. Because that next lesson set is about rising temperature in all communities. So we start with water for lesson set 1, flooding, drought, move into temperature, urban heat islands, overall global temperature
CO2.
increase, and then CO2 level rises for lesson 11, 12. Lesson 9 and 10, they're looking at fossil fuel emitting, right? So you have CO2 and greenhouse gases for that lesson set 2, which is causing these rising temperatures. Lesson set 3 is well, we know about flooding, we know about droughts, we know about greenhouse gases, we know about rising temperatures. How could communities use a mix of solutions to correct this carbon imbalance and adapt, right? So how do we correct the problem? How do we adapt with it? Is how this unit split up. So we took that unit and said, all right, how can our New Jersey students use relevant New Jersey data to support that?
So it's a very quick little overview of OpenSciED. It's like days of training, but we just wanted to give you kind of a little bit of like where some of the stuff's coming from with it. And then
as I say, if your districts are interested, it's a 4-day training. If you're new to OpenSciED, then each individual unit we showed you is supposed to be a 2-day launch. And we're certified to do that if people are interested, but that's, so I always tell people like, hey, this is a lot, because it is. But it comes with, suggested 4 days of initial training for the overall system, and then 2 days for each individual unit. And each middle school grade band has 6 units, right? So you do get suggested a lot of support.
And then I'm going to jump in now for this part of it. So we're going to go through a couple of the lessons and kind of highlight some different parts of it and then things we've added for New Jersey specific. So lesson 1 is starting out with that phenomenon in it, the anchoring phenomenon. And part of it is why are floods and droughts happening more often? So in OpenSciED, if I pull up that document, you'll see that it has them doing some notice and wonder. And they're looking at some news clips that tell stories of extreme flooding and drought in different communities. For it, so before we start this lesson, we put in an adaptation of doing our own Notice and Wonder for New Jersey specific. So looking at flooding and drought that have happened like in New Jersey. So the first link is the Notice and Wonder activity. So it takes you to the document and it has there the different evidence pieces and then how to run that Notice and Wonder if you needed directions on how to do that with the students. But the 4 pieces of evidence we use are drought monitoring. It's a little short PBS video, a news video that deals with drought that happened, I believe, back in 2017. We'll give that a second to load and I'll click. And then we also have a public notice announcement on it too from 2022 that's showing like what level we're at and looking at that information, and then a spotlight video from 2017. New Jersey's the most serious spring dry spell as well for it. And actually, sorry, that one was from 2022 for it. Then we have another evidence piece that's tying in, looking at it in a different perspective. So all of the evidence we're giving is all from different areas. So like you're reading articles about data, you're looking at it through art. So we have this peak stream flow art pieces that you can look at. So it's a sculpture that was done in the Passaic River to show from 1898 to 2020. So it has this image of it. It has this image as well to show about the sculpture. And then it has this document that goes a little bit further into detail about what this sculpture represents, what the colors are about, with the different temperatures, and then also has to deal with the amount of rainfall that's in there too for it. So then that's another piece of evidence that we're looking at. Then we have one on a news article, and that news article has to do with flooding that happened around Christmas time this just past year, so in 2023 for it, so that they would read that. And then the last type of evidence they'd be given is other ways to visualize New Jersey climate data. And this one has to do with sea level rise, tidal flooding, extreme heat days. And then it has a couple different graphs in here showing that information. So the plan would be to break our students up into groups where in each group, one student's taking on a piece of this evidence, or 2 students are taking on this piece of evidence, and they're going to sit down and read through it. They're going to write some notes down. They're going to come up with anything that they're noticing and wondering, and then they'll come back to their whole group and they'll present out to then come up with a common theme of what are we seeing, what's going on with New Jersey with flooding and drought based off of the evidence pieces that are there for it that they have with it. So that's kind of the Notice and Wonder with, and then I'll show you. So in OpenSciED, they also do a Notice and Wonder. They have set up a Notice and Wonder chart recorded in their notebook about what's happening in these communities. And they give different places throughout the US with some news articles where ours kind of ties in specifically to New Jersey for it. So my plan was to give you a couple of minutes to kind of look at this, and if anybody had questions. So I put the link in the chat for the presentation, but I'm going to put it in one more time just in case if anybody else joined, that they have access to it as well. And I'll just give you a chance to kind of look at lesson 1, look at the different evidence pieces. Normally in a PD or something, I would have us actually break up and try this out, but because there's not as many of us, I'm just gonna give you a chance to kind of look at them for a minute. And then if y'all have any questions, just let me know. And I will show you too, they have them develop an initial model in lesson 1 on what's causing temperatures to increase and how can increased temperatures lead to both droughts and floods. So they're taking from those Notice and Wonder and coming up with a model. It might be right, it might not be. What's nice about OpenSciED is they'll use this model throughout the whole unit. So they'll actually come back after they learn more about the concepts and they'll go through and actually redraw on it, or they will put notes or change it or use different colors to kind of, as they're going through that unit and better understanding what's happening, to be able to include into that initial model for it. And then during the event in February, we had people put on the Jamboard any other local events for drought or flooding that might be in your town, so that if people wanted to use those in the Notice and Wonder. So we kind of broke it up by like the 3 regions of New Jersey. So we did northern, central, and southern. So you'll see some people added some on here for those regions. You're welcome to add anything too, or you're welcome to check out what they put if there's something that you wanted to use from one of the stories as well for it. And I just want to make sure everybody got because I see there's new people in as well for it. So that's lesson 1. Anybody have any questions about that? Okay, so I'm gonna go into lesson 2, and y'all tell me to slow down a little if it's like too much information going on. So lesson 2 says what would normally expect for these places and how do we really know it's changing? So they've looked at different evidence from different places about flooding, about droughts, but like, is this a normal thing that happens or are things changing? So the next step is to look at some data with it. So the lesson does a couple of different things. For it, it has them develop a system model about Earth's freshwater. So that's part of it. Analyzing patterns and data, that's the part we're going to kind of show you. It has them start looking at like their local counties and then moving into specific areas that OpenSciED has identified. So I'll show you first the local counties. So many people might have seen this, but NOAA has climate at glance. And when you go into this website, you can pick some different things. So you can do average temperature, you can do precipitation, you can do drought index in here, and then you can change what you want to see for it about the time scale, the months that you want, the years, when you want it to end. And then what's great is you can pick New Jersey, and then you can pick specific county that you're in. And then it will give you that data for it, and it'll plot it below, and then you can actually save it and download it so that the students can see it in different ways. And then it has the data this way as well. So I did that for a couple of counties. So I did just these 3 I picked randomly, and I filled out, so there's a sheet that they go on to. So I filled that out here. So total annual precipitation, average annual temperature, and then the Palmer Drought Severity Index, and then one additional one. So this one's for New Jersey. It's the overall annual precipitation for it. And each student gets one of these to analyze their local data. And they do, and you may have heard of this, you might not have, they do, it's called I2 Wonder. And they analyze the data by looking at what I see statements. So they're going to write those down on the graphs on the chart around any patterns they see. And then what does it mean? So like, why does the direction data line mean? Is the temperature precipitation increasing, decreasing? What does that pattern mean? So what's really neat is the students are actually going to take those graphs, and I have an image here. That's why I'm pulling it up in the student or in the teacher book. So I just want to be able to show it to you. Lesson 2, let's see, where are we at? So right here, you can see where they did the I wonder, and let me zoom in a little bit more for you all. They wrote in here, so they have their the I2 statement for it. So there's lots of high points and lots of low points. Over time, some years have more precipitation and some years have less. So it's getting the students to be exposed to the data, but then also learning how to like analyze it and interpret it in a way. So that's part of the activity, is looking at specific local data for it. And I just gave some examples there. And then the second part of that lesson is they're supposed to read about specific cases, but OpenSciED picks certain ones throughout the US. They don't pick any that are in New Jersey. The closest case study they do is Boston. So these are the different ones that they've done. So they have California, they have Mississippi, they have the Navajo Nation, Boston, Washington, and then Minnesota as well in there. So we wanted to give the opportunity. So the students and for you to have New Jersey specific data. So we have 3 places that have kind of case studies and stories that can be pulled to represent things that are going on in New Jersey. So the first one comes from here. And this is part of the Rutgers Climate Institute and Energy. They have put together some different stories, different videos that deal with climate going on in New Jersey that you can pull from. So this one's New Jersey climate change impacts and responses, the coastal communities that you can click on for it as well. Climate change is a problem, can we solve it? So it has lots of different topics in here. Who's most at risk? As well, it talks about like healthcare, flood exposure, what's going on. So that's one place. Another one is the Climate Corps. And this one, graduate students have taken the data that's being collected at the Rutgers Climate Institute, and they've started to put them in 2 different stories. So for example, they have Elizabeth understanding climate risks. They have one on Wildwood coastal vulnerability assessment. And then if you go into it, it has a bunch of data that goes into that specific area and what's happening there with flooding for Wildwood. And then it just depends on which area. So even Highland Park, it goes into inland flooding for it, flood hazard assessment. So that's another area that we point out of being able to pull some of those climate stories for it. And then the last one is My Coast. And that one has some stories in there too, and some videos of different flooding that's happened along the coast as well, that you can see too for it. So that's kind of lesson 2 is kind of like a couple parts within, as like Eddie was saying, that as you see, it's not just a one-day thing. So one of it is letting them look at data, and then we pulled specific for New Jersey. And then the other one is looking at a case site. And then we just recommended some different ones that you could do from New Jersey using the Rutgers Climate Institute data that they have as well. And then the analyzing, interpreting data using this kind of procedure for the graphs for it. And I'm trying to see, and I showed you the case sites as well with it. So I'm going to give you a couple minutes to kind of click in and check out any of these, or if you have questions, I'm happy to answer them too as well, because I just gave you a lot of different sites to look at and places in a quick amount of time. And I will say OpenSciED has a reference sheet on how to pull data. Like if you're looking for specific from the NOAA site, if you go in here, I have it listed. Yep, right here. It's called the teacher reference instructions. So it specifically tells you how to access the data for certain things. So if you're looking for like temperature, it'll go into the droughts as well, short term, because it does look at short term versus long term. So these are nice, like just step by step, like how to easily pull the data without it being too complicated for it as well. And then it also has for the case sites for OpenSciED, it goes into the rationale of why they picked these locations in the US too, for it to like kind of understand a little bit more why these locations and not other places in the US as well.
Rio, can I ask you a question?
Yeah.
So I'm following you, and I really appreciate this is fascinating stuff and looks really terrific. And I clicked on your links and I followed them. So what we're looking at though today is a Google Doc, and is the New Jersey, you're talking about OpenSciED, and you're talking about right now at least a Google Doc. Is the New Jersey stuff accessible from OpenSciED directly? Is that what you're saying? Or is it we want to go through a Rutgers website?
So to get the stuff that we've added, you'll want to go through the doc and the slides that we have. It won't be on the OpenSciED website. They'll just have like their main like national one there for it.
When we're looking for case studies, then that's when we want to turn to your document.
Exactly. And if you use, let me go in, hold on, let me go out of this and I'll show you. So if you use here, a lot of teachers were saying that it was easier just to use this and like star this right here, because then all the links are right there for
Yep,
you to be able to click on much easier.
that's what I'm looking at right now. But that what we're
Okay.
looking at there, that is not OpenSciED specific. Is that correct?
Correct.
I'm just trying to,
The
when
one,
you leave, when we get off,
absolutely.
I'm going to want to follow up on this, and I need to definitely know where I'm looking anyway. So
No,
this is terrific.
absolutely.
This is a wonderful document to be used in conjunction with OpenSci. You don't even need OpenSciED to use this stuff.
Correct. So that's the thing too. Like, I think it's important, like you're saying, is that there might be a lot of this where you can implement it in other places within your curriculum, not just this unit. You're absolutely right. So that's where it says like New Jersey supplemental resources. Yep, these are just us putting in those that would not normally be there for OpenSciED. We just added that component in for it.
And so one more question, is this through
Yeah.
Rutgers now? Is this part of Rutgers University? Or is
So
it
this
Sustainable Jersey Schools or?
So the New Jersey DOE funded it for us to help do this, to kind of basically start bringing in more curriculum. And Sustainable Jersey, and Renee can jump into on this, has been really focusing on trying to get more curriculum and more resources out for teachers to teach about climate change. So they brought us on to help in developing some curriculum, some resources that then could be used. So we focused on middle school for this one. We're working on a high school one that's a little bit different, of doing different like a whole like lesson specifically as well.
Yeah, so NJDOE did fund this work, and this is kind of still in the draft stages. So anybody that participates, we appreciate the feedback and giving you access to like these preliminary documents. They'll be cleaned up a little bit more, and then according to DOE, they want us to they're free, and that we want to distribute it through every channel. So they'll be on the Rutgers website, they'll be on the DOE website. Hopefully they're saying that they're updating their website, and then it'll be posted on Sustainable Jersey. So the idea is we want everybody to take advantage of them who's interested, and we're going to try to distribute it as far and wide as possible. And we are doing sessions like in the fall conferences, the science convention, and the principals and supervisors, and NJEA, to try to get the message out that these are free. And by using New Jersey specific data and information, it makes it real to students, and hopefully, encourages them to go to the next step, which the last lesson is like solutions. What kind of solutions can anybody, but we're encouraging students to think about what they can do in their communities to address these issues.
And then we have a question in the chat about recommend teachers facilitate conversations around the messiness of real data on graphs. So I will say this, like analyzing and interpreting how they have this I2 is a great way, because the kids are actually writing on the graphs, like looking at the graphs, seeing all of that messiness of what's going on, so that they can actually start to write questions. And then part of this, and I don't have this on here, of this lesson is to come back whole group and actually have the conversations of what they're seeing, what they're interpreting, what they're viewing for it, as well, to kind of have some of those conversations with it. As for other ones, I'm gonna have to think a little bit and get back to you on what could be some other different activities of looking at it. I'm trying to think, because we did another one where we displayed it around the room and they were able to like walk around and make comments and notes on it as well for it. But we don't get too much into the messiness, but you bring up like an important part for it. So if I don't answer your question now, if I can get your email, I will email you later too, and I can give you more info on it as well. I'll talk with Eddie a little bit more for it too. So the next, any other questions before I go to the next part? Okay. So the next one is, we kind of move into the next kind of subsection, and I pulled up some stuff for lesson 9 and 10. So they're moving now into looking at temperatures rising and kind of the change in the amount of CO2 in the atmosphere. So there's two things that I kind of want to point out with the lesson. There's a couple things going on with it, and I'll pull up so you can see. They're carrying out investigations on gases being trapped in ice. They look at ice core samples, so it's going into more of that broader area of like globally kind of looking at data for it. And then they have them use a program called Tuva, and I don't know if anybody's used that, but it's a data tool. For middle school, that's what they use. For high school in OpenSciED, they use CODAP. So I'm going to show you both of them just because I do think they're also a great place to be able to get data. It is free to get an account with them. So I'm going to show you that first. If I click on the right link, it would help you all. Here we go. So OpenSciED, they created a whole page, and then they use Tuva down at the end of it after they look at the core samples, and then they go through the data. And what's great is on this page, it specifically tells you what to do. So it says drag the year to the x-axis. So they're actually doing that. There we go. And then it tells them to then drag the y over, or the CO2 to the y-axis. And then it lets them see that data changing and what's going on with it. But if you go to the actual site, there's some teachers who took that data and they created an activity, a lesson. So this is one of them that's free, that a teacher took some of that data that OpenSciED had in it. And it's great because you can try it as a student. So in this assignment, I can hit try a student and go through. It has like the description, the learning objectives, and then it goes into like an introduction, and then it has specific questions and specific things for the students to do within it. But let me show you, before I give you a chance to kind of play with that, what Tuva is. So what's great is you can create your own classes. It does link with Google Classroom. It does link with Clever. The only annoying part is there's a free version and there's a premium. You can actually upload your own data sets and create your own activities or lessons for the students. You can look through their library, and then you can actually click so that like you only get free ones. And then you can kind of see which ones are there for free. So like we used the Urban Heat Island one before with it. There's another one on long-term atmospheric changes, which that might go with the OpenSciED data that we're looking at too for it. So you can see there's a lot of different ones in here. But that's what lesson 9 is, getting them familiar with using Tuva, and then it's looking at the ice core and kind of seeing the CO2 that's trapped in there. And then before I show you lesson 2 or 10, they kind of tie together. I just want to show you the other data tool is CODAP. That one is also free. The people who created OpenSciED for middle school,
I never got a red one.
they didn't. I'm just gonna. I don't know if I can mute. Okay.
Yes, I usually get one.
Is it in here?
People
In the-
for. Hold on 1 second. I'm just gonna.
Yeah, but no, I won't. I won't. I get very flustered.
If somebody's watching.
Patch.
Okay.
Welcome, Patrick. I don't know if you wouldn't mind muting your microphone.
Sorry.
That's okay.
I was like, all right, can everybody else tell him that? And then thankfully everybody else was able to chime in. So I was like, oof, he like malicious.
Or Renee, you might have the ability to be able to
He was
mute it.
Give
me 1 second.
more.
Okay. All right. So the other data tools I want to show you is CODAP, because that one's also free. What happened is OpenSciED one group of people developed the middle school and they went with Tuva, and then another group of people developed the high school and they went with CODAP, instead of thinking, oh, let's use all the same for both grade levels. But this is another place that you can actually do data analysis, and they have different ways of pulling data in and then letting the kids go through and use it. So you can go in and try it out as well. It has middle, high school with it. They come from the Concord's consortium. So if you've ever used anything with them before, they have a lot of stuff with climate change. That's what Eddie used a bunch for his dissertation. So they have this one as well that's free to go in. So I wanted to just be able to show you both. And then I also linked the middle school simulation library. So it has all of the different simulations, not just the one that has to do with this unit, but then you can click on a grade level, or you can pick a different science domain, and then you'll see all the different simulations that they've put together as well for you. And then the same thing for high school too, which is nice for it. So I'll give you a minute in a second till if you want to try out like the vamping up or vamping up the heat trap or checking out the ice core one. But lesson 9 and 10 kind of go together because in 10 they're then analyzing and looking at those graphs. So they're looking at one on population growth and CO2 graph, and then it has to all do with the whole United States for it. So we wanted to give you some New Jersey specific data, so I'll show you that in a second. But you can see that you can put in the years, and then it has a couple different things. So coal consumption, annual CO2 emissions, population. And what's neat is you can actually put more than one on the different axes as well to be able to see for it too. So there's a lot that you can kind of do, and you can change the type of graph that's going on in there as well with it. And then we put in here some resources that have specific New Jersey CO2. So this one here comes from, it's the state climate summaries from 2022. And when you go in here, you're going to see a couple of different ones. So this graph we use a lot for New Jersey in different Climate 101. It shows the temperature changes from the 1900s to 2100, their predictions. And then it has the graph showing what's been observed, and then what would happen if we lower our emissions, where we would be, and then what would happen if we had higher emissions and where it's going. So it's a great way to be able to show the students what's specifically happening in New Jersey and what we're observing with it, because we also have some different rules and regulations than other states on what we're doing with car emissions and other emissions that are going on with CO2 levels in New Jersey for it. And then there's a couple other figures in here as well that could go with some of the other stuff we talked about within it that have to do with precipitation and then other projections and graphs that we've used for some of it. So that's one place to get some CO2. And then this is another resource that has to do with greenhouse gas inventory. And this comes from the New Jersey DEP. And it has a whole bunch of data over here as well on the historical trends of greenhouse emissions, the type that it is. So again, comparing it to the world that they're looking at with OpenSciED here specifically for New Jersey within it as well. So it has a couple different data sets here for New Jersey, and then comparing global trends as well within it. And then the last one is US energy again, but it's just giving some other data too to kind of show where that energy consumption is coming from as well. So it's got some different graphs and resources for it that you can see too. And then these are some of kind of the questions as they're looking through those graphs that they're looking at some of the visualizations, thinking about where is it coming from, why are they there, like that rise in CO2. It also has some more of the data that it's looking at for the world compared to then the ones that we had for New Jersey, for the students to kind of compare both of those. And then again, this one's world data of energy consumption, and then could go back to the one that we showed of just New Jersey to be able to give them the opportunity to kind of compare where we are at compared with the whole world too. So I'm going to give you a couple minutes. If anybody has questions on any of that, I'll answer any of it. I would say if you want to jump into Tuva and just try it out or sign up, it's free to sign up and like look around at some of them. Like I said, trying out the student version, which I'll go back to that link right here, I thought was super helpful, because then you can kind of see like how it's built in the questions and stuff like that. And I think we have a couple questions or in the chat. Okay.
Can you put the link in the chat, please?
Yeah,
Ramp up the heat.
absolutely. Here you go. That should take you there. You might have to like sign up, but it is free to sign up as well.
Overall, what's the time frame to do a lesson or to do a unit?
So lesson 9 and 10, I can tell you right now. Let me go into, let's see, this should tell us how many. Yeah. So lesson 9 was 1 day. So that one is not a super long one. That one is just showing them this site, which I can click on for you. This site they're using and going through and reading and watching the videos and answering some of the questions and working a little bit with that graph. But then lesson 10 is 2 days because they're doing a lab in there as well, or an investigation, besides looking at the data that we were looking for it. Lesson 1 that we did took 3 days. And then lesson 2 took 3 days. So that's a total of 6 days, 6 already there. 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 27, 28. So this one's it says at the bottom, sorry, 33 days total is how many this unit is what they're saying. I will say, one school's tried it out, Westfield, and they had to cut some of it because they weren't able to fit it all within the time frame of it. So that's where like Eddie likes to point out, and I think it's nice, is that this here, you could look at, okay, this is all grouped together. Where might I be able to pull one lesson away and still be able to hit it? Where might I be able to pull a lesson from this section and then from the third? And that seems to be how some people are editing it a little bit to be able to fit everything too.
Brielle, do you know what the assumption is when it says 2 days or 3 days? Like what the length of time is? Like
I'm assuming they're going with like 45 to 50-minute classes for it, but I would have to double check on that. But that's what I would think is the like on the safer side of it. I know some schools have 60 to 80, but I know a lot of them are more closer to 45, 50. I don't know, Veronica, what is that about your
We are 45-minute class periods. And then when you said 33 days, I was like, yeah, that's about a marking period because a marking period's 40 days or so.
And there's other stuff like, and that's it. So that's where it's like the cutting down is definitely, and if you're interested in like doing this unit, we can get you in contact with Westfield because they've implemented it. They're one of the few that have gotten through all of the units of OpenSciED. We haven't met many districts that have been able to get through all of the units yet, as well for it. Yeah. Perfect. So that is for 9 and 10. So I'm going to show you lesson 16 and 17. So all the other ones were the students kind of collecting data, gathering information, doing investigations, wondering. The last part of the unit is for them to actually then take what they're learning and apply it into coming up with a solution that works best for their community, with thinking about temperatures increasing, thinking about greenhouse gases, in all of those different areas. So we kind of combined the resources for it. Lesson 16, they're going to use the case studies that I showed you from the beginning and see how those places have addressed their communities and climate change. And then lesson 17 is where the students actually get to come up and design and figure out and assess their community that they live in. So for it, OpenSciED has created a couple of sheets for the kids to kind of use as outlines to work with. So one of them is argue for the best solution to solve a problem in your community. So they're going to use this sheet to help them kind of come up with that. And then they also have a community resilience plan. So what they're creating, the changes in their community, who are the stakeholders that are being affected. So we put together some different places to be able to actually for the kids to get this information. So Renee's got a great couple information with Sustainable Jersey that'll address it. And then I have a couple here that will give you as well for it. So I can go to the next slide, Renee, and let you talk about your 3, and then I'll just go, and then I'll come back and talk about ours, if that works for you.
Yeah, sure. So, what we're trying to do is kind of promote that students can use the Sustainable Jersey municipal and school frameworks to identify actions that municipalities could take to address climate change. And so you'll see here's just a bunch of some of the actions, that a snippet of the actions that are related to energy, which obviously directly relate to climate change, and then kind of emergency management and resiliency, like the heat island assessment and mitigation plan. So these are, if the students look at the actions, it kind of gives them an overview of what it is and how a community might go about doing it. And then, do you want to go to the next slide? And then similarly on the school side, there are school-based actions that that students can be directly involved in implementing, like things with the school grounds or waste reduction and recycling. A big topic right now is food waste and food recovery programs. And we just came out with a couple new actions on that and a toolkit for addressing food waste in schools. And then, of course, the energy efficiency stuff and promoting locally grown foods, school carbon footprints, green purchasing. So just kind of perusing through like a real life program, it might be interesting for students, you know, to take a look at some of these things. And then the next slide. And then they can actually look up, if they're interested in a particular action, they can actually go on our website and look at towns or schools that have done these actions and what the documentation is that they provided. So this is just kind of instructions on how to do it. On the homepage for both the school website and the municipal website, we have this map, and you can click on it, and then you can filter it by certified or not certified, by what county you're in, and you can also search by action. So you could look at silver certified towns in Bergen County that implemented energy efficiency for municipal facilities. And so then they could go right into their application and click on all the documentation that the towns provide to see what was actually done in their town or in towns around them. Do you want to go to the next slide? And then this shows you, after you do the search, it will come up and you just click on Cape May or Chatham, whichever shows up from your search criteria. And you can kind of scroll through their application and look at all the things they've done and hone in on. If you search by a particular action, you can, again, look at what the town actually did. So it's just a good way of showing students that towns are taking action and schools are taking action to address climate change, and you know, they can also be part of the solution. Any questions on that?
And it's a great resource for them to be able to fill in for that community resilient plan, as Renee is showing, because it shows what's already going on and maybe what they can enhance, or if their community's not doing anything, like where could they start comparing some other places. And they do give in OpenSciED another resource as well, the Climate Explorer, which allows them to actually look at their location and see the rainfall, see the heat, the emissions, like what's happening. So I think that's a great one. I don't think it has to just be used for here. I want to go into the site for you, which hopefully I didn't link. Sorry, hold on. I will put the link in right now, or if it's here, but I don't think it. No, hold on. Let me pull it really quick for y'all. It is right here. Okay. And then my apologies. So I can just show you a little bit about this site, because I think this is super helpful for kids too, to look at getting the data for it. So if you just type in here, so I could put New Brunswick, New Jersey, And then it's going to give me some different maps in here, climate graphs, maps. It's going to have flooding in here, historical weather data, trends, and then they can actually click on it. And then they can pick certain seasons. So this one's just annual for it. You can change here all the different types of temperature options they have, precipitation, and then some other ones. And then it has from 1960 to 1999 over here, they can change. So it has 2020, and then you can change, do you want higher emissions? Do you want lower emissions? And then they can actually see the comparison of what is going on for it. They also have it graphed for the students, and then they can see the lower. So thinking about what action plans they're doing and thinking about if they lower it, what will happen versus if they don't do anything and it keeps increasing as well for it. I just find this one to be super user-friendly and easy to read, which is nice for it as well. And then you can, like I said, play with other things with it. So this one I could do lower emissions. This one I could do higher. I could have the same years on here. And then I could pick just summertime and let them see the difference of what's happening. Or I could do winter or annual. And then you can also download them as well so that you have the different maps so that you'd have access to it that way for them to see with it. And then I could do total precipitation, what happens for it, and then historical trends or other ones. So there's lots of different ways that they can look at data to help with when they're starting to come up with the plan for where they live and what they might be affected by for it too. And then we also put in a couple other places that you could get further data from. So the New Jersey Future Guide to Local Climate Change Adaptation Planning. These are definitely more documents that have come out from the state. So it is a lot of like reading. So it's more of like going through, filtering, and seeing what you might want for your students, depending on kind of where they're at with the information. But you can download the whole report for this one on their action plan with it. And then we also have in New Jersey climate change statewide resilient action plan that the New Jersey DEP has up on their site, and it goes through kind of New Jersey extreme heat resilient action plan. So what New Jersey in whole is planning and working on in their priorities for then the students to think about in their local area. And then the last one is a 2-year report that has to do again with climate change resilient strategies as well for all of New Jersey for them to see too with it. So those are the lessons that we kind of highlighted for it. If anybody has any questions, please ask. I am going to show you a couple other things as well, just so that you have it too. So I linked in here the presentation that we did the other a couple weeks ago. That one was for different content areas, and I just wanted to show you. So there's stuff in there for like art, there's stuff in there for social studies, ELA, so a lot of like integrating some different subject areas. So if you do work with other subject areas or your colleagues are interested, you can show them some more of the data, but based around specific standards for different subject areas that you can have access to in there. And then we also put in several other extra resources of different ones that we always recommend with doing climate data and climate resources that you can have access to. So these were just some key resources. Some of these are in the other lessons that we didn't go through for it. And then there's some primary resources. There's some lesson data resources as well. New York Times has great lessons that are completed, and they're free for climate change education as well for it, and then some stuff with NOAA as well. So I did put those extra in there just to give you the opportunity to see with it. Does anybody have any questions? Anything they want me to highlight or go back to for it?
Patrick?
Yeah, hi, good afternoon. I'm sorry about unmuting. I was trying to
That's okay.
multitask and I blew it. And hello to Sonia. I
Understandable,
used to work
teacher
with Sonia
world.
years ago in Clinton Township. So Sonia, how are you? Yeah, this document here that you have, did you share it with us, or is it just, this is the link up here?
It is the, hold on, let me make sure you have the right link. So let me give it to you just in case
Okay.
if you came in after I put it in.
Yeah.
This will give you the link to the whole presentation.
Yeah, because
So
I
then you'll have
jumped in
access
late.
to all of it.
Cool.
Yeah, that's okay.
Thanks. I attended one of your last seminars. I don't know if it was the last one you were just talking about or not, but it was
Okay.
great. It was with the Tuva labs and stuff, and
Yeah, yep,
it's a
yep.
some great resources. So I just want to make sure I grab onto these. Thank you. This is
No
awesome.
problem. Absolutely. Yeah, that should give you everything there too. With it. And I didn't go over, and we have a little bit of time. Let me see, there's a I can show you also, and Patrick, you probably saw this one, but the NJ Adapt tools, we use these in a couple of the lessons as well. I'll just give you a quick markers. Yeah, here they are. And I'll put this in the chat so you all have it. They are in the lessons though, within the story map, so that you have that too. But this also has great data if you're looking for, this is the climate snapshots, which are another one to get a lot of stories from. There's a climate dashboard. The flood mapper one is fun because, I mean, I think it's cool because if you're looking like where you want to buy a house and see flooding, but it has lots of different tools to show students about flooding, and it goes well with lesson 1, lesson 2, lesson 4. I linked them in that story, but just because time, I figured I'd show you a little bit of it. It has a whole thing of like walking through how to use it. But what's nice is you can put a specific location here. So I could put, let me do Sandy Hook. I'm going to do somewhere by the water. Let's see if that comes up though. No, we'll do Wildwood, New Jersey. So it'll bring you to a specific location, and then you can pick different things that you want to put. So like flood hazards, so you can change the sea level. You could put like what it was for Sandy's storm surge on there. You could put FEMA flood zones on there as well. You can add other parts to the map too. So like if I wanted to put all of the schools on there so we could see where they're located, you could hit schools so that it would add it to it as well. But then it also has in here for it, let me go back, environmental hazards. It has land use, land cover, boundaries, infrastructure. So there's lots of things within this map to be able to see different things that are going on. And then you can remove them or decrease them or change them on here with it. So let me get rid of the FEMA one so that you can see. So with Sandy, this is how it looked for the storm surge that happened. And then the schools should be on there. Let's see if why they're not showing up. Hold on one second. Not sure why the schools are not showing up.
Maybe because they're hidden by
But
the dark blue.
I know, I think you're right, but it
Yeah,
is
you
weird
could
because
see.
usually, let me shut off. Let's see, are these the schools? No. Usually you can see them, so it's neat to see, like, for kids to be able to be like, oh, where's my school located within it as well. So if I hit add, it's not loading very well for me right now, but that was just an extra one I kind of wanted to be able to show you for it. But like I said, if you go in to the map of the story outline, we have that tool in there for you. I can show you really quick. The NJ Adapt. So right here, NJ Adapt Flood Mapper has it on this one for you, and it gives you a little bit more information like in the document as well for it. Any other questions? Oh, and we got you guys added more resources. I love it too, so that's super helpful.
Yeah, I've been just, I figured I'd share them because they were kind of similar, and I remember last time too, I had thought of these, and I use ArcGIS quite a bit for some data analysis that's similar. And then they also have something called geo inquiries, where they're like pre-made lessons that you can kind of follow along. You could also edit them. So I typically will edit them and tailor them a little bit towards more what I'm doing. But it's great. And National Geographic just partnered with Esri, who makes this ArcGIS program, and they made like a really student-friendly version, where it allows you to add different layers so that you can analyze like flooding data or climate data. And they kind of have some pre-built modules almost in there too for different layers of data. And it's really simple to use and very, it's very, very user-friendly. So, and I teach middle school, so it's been good for middle school. So I'd imagine high school is great, probably even in elementary school as well.
Oh, that's awesome. I just added them in just in the notes part of like feedback so that if anybody wanted to access them, it'll be there to be able to get to them as well for it.
The ultimate goal with at least the climate change education office at DOE is really to encourage like interdisciplinary approaches to integrating climate change. So working with the language arts teachers to kind of use some of the state reports for students to read as part of that curriculum, and then kind of they have that background going into science. So sharing like these resources with your colleagues too will help kind of build student knowledge across the different through the different content areas, and not just in science per se.
Oh, absolutely. And what's nice is a lot of the OpenSciED tools, like for them analyzing and notice and wonder and all that, tie beautifully with the English standards of informational text and stuff for it. So definitely, if you have, like, if your colleagues are interested, please share. And if they have questions, we're happy to answer too, if they are looking for support or anything.
Or any specific resources. There are so many out there, but if
Mm-hmm.
you're looking for something, we may be able to help you.
Yeah, I guess I put my En-ROADS thing in there, and when I thought of it, it's really not New Jersey centric. So it's a global simulator, but anytime I think of climate change, it really is a wonderful tool, and it is interdisciplinary, and it does generate data. It generates the data that you could use in the science thing that's because it projects out to the future pretty much. So you could use that data, but sorry, I guess it
That's
wasn't,
awesome.
it wasn't perfectly appropriate. Kind of a tangent to this conversation, but I'd love to have one with you about it anytime. But this is great stuff. Thank you so much for all this. I know I'm going to be using it for sure.
Great. Well,
No problem. I know, and it's a lot of stuff. And that's the thing though, like you said, with like climate change is global. So it's like, yes, we are looking at New Jersey, but like when we talk about the ice sheets and sea level rising and all that, it still affects us. So it's like you can't not get one without the other. So there is a matter of mixing both. So
right. That's great. All right, if there's not any other questions, we are gonna post this video, or the video of the meeting, on the website and the PowerPoint. So and I'll email everybody that was here and everybody that wasn't here to let them know, and that will be probably sometime next week because we have a big conference tomorrow. Well, thank you all for participating, and please reach out to any of us. You have the contact information if you have any questions or are looking for resources, like I said.
Thank you very much.
thank you so much.
Thank you.
You're welcome. Thank you for joining. It was great to meet you all.
Yes.
Great. Thanks. Y'all have a good night. Thank you.
Thank you.
You too.
Bye-bye.
Bye.
Bye.
Okay.